Good morning, students. So today we are going to start with a new topic. The name of the topic is amines. Okay. What do you mean by amines? So amines. Okay. So these are the organic compounds. Okay, which are containing nitrogen. Which are containing what? Which are containing nitrogen group. Okay. So these are the derivatives of ammonia. So how this ammonia is formed? This amines are formed. So these amines, they are the derivatives of ammonia. Okay, in wherein, so you know the structure of ammonia, right? So the structure of ammonia is something like that. See here, NH3, NH4. Okay, NH4. So this is the ammonia structure. So these are said to be the derivatives of ammonia. Okay, in which one, two, or all the three hydrogen atoms of ammonia are replaced by a alkyl or a aryl group. Now you know what is the alkyl group and what is the aryl. Alkyl group means what? Alkyl group is a straight chain compound. Okay, it can be a straight chain aliphatic compound. Okay, you can see aliphatic compound wherein it can be a straight chain or it can be a branch chain. So aliphatic aryl group means what? Aromatic compounds. Okay, aromatic compounds. So these are called as a derivatives of ammonia, wherein you can replace one or two. Okay, you can see one, two, or all the three hydrogen atoms. So ammonia is NH3, right? So NH3. So this is the structure NH3 like this. Okay, so either one or all three hydrogen atoms can be replaced by an alkyl group or a aryl group. Okay, so they are called as the amines. So amines are called as the derivatives of ammonia, wherein all the three hydrogen atoms, one or all the three hydrogen atoms are replaced by a alkyl or a aryl group. Okay. So we'll see some of the important points. So So in this chapter, we are going to study about the amines. Okay, we are going to study the classification. We are going to study about the physical properties. We are going to study the nomenclature. Okay, some important nomenclature. We are going to study some of the important this what amines, wherein we are going to study about the common name, IUPAC name. Okay. Then we are going to study about the structure of amines. Then how we can prepare the amines. Okay, uh, so physical properties, okay, chemical properties. So these are the things which we are going to cover in this particular chapter. So amines, as I discussed, okay. So we'll see the classification now. So amines, they are the derivatives of ammonia in which one or more hydrogen atoms can be replaced by a alkyl group or a aryl group. Okay. So they are classified as primary amines, secondary amines, and tertiary, depending upon the number of hydrogen atoms. Okay, replaced hydrogen atoms. Suppose now, what is this primary amine? Okay, in this, only one hydrogen atom of ammonia is replaced by a alkyl or a aryl group. Now, NH3. So, out of this NH3, only one hydrogen atom, that is NH2. Okay. So, one hydrogen atom of ammonia is replaced by a aryl group or a alkyl group. Okay. So, the example can be CH3, CHNH2 in case of a alkylamine. So, the name is what? Methylamine. So, the name is methylamine. Okay. The name is methylamine. So these are the examples of primary amine. So this is for alkyl groups. Okay. So when one of the hydrogen atom is replaced by a alkyl group, then it is a methylamine. Then the second one with respect to aromatic. Okay, if we take a benzene ring, okay, if we one of the hydrogen atom is replaced by a benzene ring, then the name is what? The name is aniline. Okay, so these are the example of what? This is an example of primary amine. So when one of the hydrogen atom is replaced by uh, alkyl group or a aromatic group, then it is called as primary amine. So next we are going to see is the secondary amine. So what do you mean by secondary amine now? Secondary amine means what? Two hydrogen atoms of ammonia are replaced by a alkyl or a aryl group. Okay. So how it is generally represented? So this is generally represented as RNH2. Okay. And this is generally represented as RNH. So one more hydrogen is replaced by R dash. Okay. Two alkyl or a two aryl group. So we'll take an example now. So the alkyl group CH3 and H, okay, and CH3. So what is the name? It is dimethylamine. So the name is dimethylamine, okay. And one more example with respect to aromatic amine. So I'll take one benzene ring, okay, and NH, and this is CH3. So when you are naming now, so this is a phenyl group. Okay, this is a phenyl group and this is a methyl group. So we have to name it according to the alphabet. So M come first, right? Then comes your P. So it will be methyl phenyl amine. So this is the naming. So these are the examples of, so this was for primary and this is for secondary. So in primary, only one hydrogen is replaced by alkyl or aryl group. In secondary, both the two hydrogen atoms are replaced by alkyl or aryl group. So next we are going to see is the tertiary amine. Now, what do you mean by tertiary amine? Tertiary amines means what? Here, all the three hydrogen atoms of ammonia are replaced by a alkyl or a aryl group. So how it is generally represented? It is generally represented by, so this is R1 and this is R double dash. Okay. So, so this is a tertiary carbon. So here the nitrogen which is present, it is a tertiary in nature. So I can give example of alkyl group. So in, okay, CH3 and CH3. So the example, what is the name? So there are three methyl groups. So it is a tri. Okay, we give the word as trimethyl amine. Okay, so this is example of a alkyl amine. Now alkyl tertiary amine. Okay, so now we'll take an example for a aromatic group. So NCH3 CH3. Okay, so the name is dimethyl. Okay, dimethyl phenyl amine. Okay, dimethyl phenyl amine. So based upon the replaceable hydrogen atom, it is classified as primary, secondary, or tertiary. Okay, so atoms in the ammonia molecule can be substituted by alkyl groups or aryl groups. Okay, so accordingly. So next we are going to see the physical properties of amines. So the lower aliphatic amines. Okay, aliphatic amines means aliphatic, either the straight chain or the branch chain. So the lower, okay, lower means with a less number of carbon atoms. So the lower aliphatic amines. So these are gases. Okay, so they are usually gases and with a fishy smell. So how the fish smells, right? The same way, these lower aliphatic amines they smell. So they smell like a fishy smell. Okay, they have a fishy smell. So primary amines with three or more carbons. So the higher ones, okay, that is the primary amines with having more than three carbon atoms are liquid in state. Okay, the lower aliphatic amines they are gases. The middle ones, okay, with three or more carbon atoms, they are liquid, and the higher ones, okay, higher that is more than maybe six or maybe more than five, six, so they are solid in state. So this is the state of the aliphatic amines. Okay. Next, boiling points. Primary is greater. So the boiling point in case of primary is greater than secondary and then the tertiary. So and lower aliphatic amines they are water soluble. So they are soluble in water. Why? Because of their hydrogen bondings, right? Because of the hydrogen bonding which is present. Okay. So because of this, the okay, they can form the hydrogen bonding with the water molecule, right? So because of this property, they are water soluble. And however, what will happen? The solubility go on increasing. Okay, sorry, decreases with the increase in hydrophobic alkyl group. So because of, so firstly, where so because of this hydrogen, okay, at as you can see the structure, okay, that is hydrogen atom is present. So this hydrogen atom so in the amine can form a hydrogen bonding. Okay, the amines can form hydrogen bonding with water molecule, so thus they are water soluble. But as you replace this hydrogen atom with the alkyl, that is hydrophobic alkyl groups, okay, which is not having free hydrogen atom, which can uh, form hydrogen bonding, so the solubility decreases. So such compounds, they further do not get soluble. Okay, then tertiary amine does not have intermolecular association due to absence of atoms. So as the number of hydrogen atoms are irreplaceable, okay, further they cannot form because of the unavailability of the hydrogen atom. They do not form the hydrogen bond formation. Okay, so this is the reason. So we'll see the structure of amine. So the nitrogen atom in the amines is sp3 hybridized. Okay, it is sp3 hybridized because the nitrogen is, okay. So the nitrogen is connected to single bond. So it is the hybridization of this nitrogen is sp3 hybridized. The three hybrid orbitals are involved in bond formation. So the three hybrid orbitals are involved in this bond formation, and there is one lone pair of electrons which is giving it a pyramidal shape. So the shape of this amines is pyramidal, okay, because of the presence of one lone pair. Okay, so nitrogen is 7, so it is 1s2, 2s2, and 2p3. Okay, so you can see when you write the outermost shell, okay, 1, 2, 3. So this, okay, now there are how many hydrogens? There are three hydrogens. So there are three hydrogen with the one, so that is 1s1. So three hydrogen means three bond formation. So 1, 2, and 3. Right. So these are the three bonds. Okay. These are three hybrid bonds. So these are three hybrid bonds. Okay, and this is one lone pair. So this is one lone pair, and this is three bond pair. Right, you can see, understood? So these are the three bond pairs, and this is one lone pair. So because of this lone pair, it is having what shape? The amines are having pyramidal shape. Okay, so remember, so the nitrogen in the amine is three hybridized. So three bond pairs are formed. Okay, between the nitrogen and alkyl groups, and there is one lone pair, so which gives a pyramidal geometry shape. So next we'll see the preparations of amines. So by reduction of nitro groups. So first one is reduction of nitro groups. So when you take nitrobenzene, so this is a nitrobenzene. So when you react the nitrobenzene, so nitrobenzene, okay, in the presence of tin HCl, it is in the presence of tin HCl, which is a reducing agent. So tin HCl is a reducing agent. What it is doing? It is converting your nitro NO2 to NH2 group. So nitro is reduced to NH2 group. Okay, what is done? There is removal of oxygen. Okay, removal of oxygen and addition of hydrogen. You can see, right? So this is undergoing a reduction. It is undergoing what? It is undergoing reduction. So we are converting our NO2 group to NH2 in the presence of tin HCl. Okay, tin HCl is a reducing agent. So one more example, nitro so another reagent or reducing agent which can be used is Fe. Okay, you can use the active metals like tin, okay, iron, zinc, okay, with some acid like HCl, and this acts as a good reducing agent. Okay, so here again we are reducing our nitro group to amine group. Okay, so this is the first preparation, okay, by where we can reduce our nitro compounds to amine group. Next is a reduction of nitriles or cyanides. Okay, what do you mean by nitriles or cyanides? C triple bond N. Okay, so these are called as what? These are called as the nitriles or cyanide group. So what we are doing now, we are reducing this. So we are going to reduce this nitrile or of cyanide group. So reduction can be possible in the presence of nickel. Okay, Nickel is a good, what you can say, reducing agent. Then we can add hydrogen, okay, in the presence of liquid ammonia. Okay, liquid ammonia, that is sodium amalgam. It is called as sodium amalgam, that is NaHg and ethanol. Okay, what is done here? There is addition of, so it is C triple bond, okay, N. So what we are doing? We are doing reduction and you get CH2 NH2. Okay, CH2 NH2, you can see, right? So what is happening here? Hydrogens are added across this triple bond. Okay, so we are doing reduction. So this is another preparation. The next is Gabriel thalamide synthesis, and by using, so this is very important synthesis, Gabriel thalamide synthesis, and this synthesis used for only preparation of primary alkyl amines. Okay, we can prepare the Gabriel thalamide, that is, we can prepare the uh, amines by only okay, we can only prepare the aliphatic primary amines. Okay, we can prepare only the aliphatic primary amines from this reaction. So what we are going to do, we are going to treat, okay, we'll see the reaction directly. So we are going to take a thalamide. Okay, so here, what we are doing in this method, we are taking the thalamide. So the structure of thalamide is like this. So this is a structure of thalamide. So thalamide, we are treating it with a ethanoic KOH. Okay, yeah, ethanoic KOH. That is, ethanoic KOH is what? That is potassium hydroxide. Instead of preparing in water, they are going to prepare it in the ethanol. That is alcohol. Okay, ethanol is what? It is a alcohol. So we are going to prepare the KOH in ethanol. So thalamide in the presence of ethanoic KOH. Okay, we are going to get what? We are going to get a potassium salt. Okay, we are going to get a potassium salt of thalamide. So what is happening? This hydrogen atom, okay, is replaced by a potassium. Okay, we are replacing it by potassium by treating it with a ethanoic KOH. So we get a potassium salt of thalamide. Now this potassium salt of thalamide, we are going to further heat it. We are going to heat it with what? We are going to heat it with a alkyl halide. Okay, we are going to heat it with the alkyl halide. What is happening? This potassium K plus is replaced by R group. Okay, and we get what? N alkyl thalamide. Okay, then we are going to get what? N alkyl thalamide. Okay, so N alkyl thalamide is obtained. Now this N alkyl thalamide, okay, N-alkyl thalamide is further, it is undergoing what? It will undergo hydrolysis. Okay, it will undergo base hydrolysis. That is in the presence of a base like NaOH. Okay, and what is obtained? This, okay, here the bond is broken. Okay, so like this. Okay, and what we get is here NaOH. Okay, so here COONA. So this becomes ONA, and this becomes C double bond ONA. Okay, minus minus and plus primary amine is octane. So we get a sodium thalate. So this is called as the sodium thalate. So the name is sodium thalate. Okay, so this is a Gabriel thalamide reaction. So this is what? Gabriel thalamide reaction. So by this reaction, okay, from this what is that? Gabriel thalamide synthesis, it can be only from this we can prepare the primary aliphatic amines. Okay, aromatic primary amines cannot be prepared by this method because the aryl halides, that is haloarenes. Here, what we are going to take? We are going to take alkyl halides. If you want to prepare the uh, aromatic amines, then we have to take here what? Aryl halide, right? But aryl halide, they do not undergo. nucleophilic substitution with an ion formed by thalamate. Okay, thalamide. So because of this, only aliphatic primary amines can be prepared. Okay, and we cannot prepare aromatic primary amines. So I hope this is clear. So next important one more reaction, that is Hoffman's bromamide degradation reaction. Okay, Hoffman bromamide degradation reaction. So Hoffman, he developed a method for preparation of primary amines. How is this preparation? We are going to take a amide. Okay, we are going to take a amide. So what we are going to do? We are going to take a acid amine. Okay, so this is a acid amide. So acid amide is treated with a bromine, okay, in aqueous or ethanoic NaOH. So either you can take aqueous or ethanoic solution of NaOH or KOH, okay. And what will happen? It gives you a primary amines, okay. It gives you a primary amine, okay. Here, what you can see, the amine which is formed, okay, the amine which is formed, it contains one carbon less. It contains one carbon less than the parent amide. You can see here two carbons are there. Here only one carbon is there. So the in the product side there is one carbon less. Okay. So this reaction is called as degradation reaction. So this reaction is called as what? Degradation reaction. Okay. So this is also a very important reaction. So we'll prepare now. So I can take this R as CH3. So CH3 C double bond O NH2, okay, plus Br2 plus 4 NaOH. What is obtained? You will get CH3 NH2 plus Na2CO3 plus 2 NaBr plus 2 H2O. Okay, so we are going to get what? Methanamine. So this is a methanamine. Okay, one more reaction. We'll take a benzene ring now. Okay, we can get aliphatic, we can get primary amines. Okay, either it can be a aliphatic or aromatic. So we'll take a benzamide. So plus Br2 plus 4 NaOH. Okay, you treat it with a base. You get what? Aniline. Obtain what? Aniline plus Na2CO3 plus 2 NaBr plus 2 water. Okay, so this is a important reaction, that is Hoffman. So Hoffman bromamide reaction, then your Gabriel thalamide reaction, very important reactions. Okay. Then next is some of the important reactions. So we are going to see, that is alkylation. Okay, alkylation, that is all the three types of amines can react with alkyl halides to form quaternary ammonium salts as the final product, which is provided alkyl halide in the is present in excess. So what is obtained? So all the three types, okay, all the three types of amines, they react with the uh, alkyl halides, okay, to form quaternary ammonium salt. It forms what? It forms quaternary salt as the final product, provided the alkyl halide which is present, it should be in excess. It should be in excess. So we are going to treat ethanamine. So we have taken what? Ethanamine plus bromomethane. Okay, you get in. So the alkyl halide is taken, should be in excess. Okay, it should be in excess. First, what is happening? One of the hydrogen atom is replaced while NH2 NH2 plus CH3Br. So this is the alkyl halide group. So what is happening? So one of the hydrogen atom here will be replaced by the methyl group. So you obtain CH3, CH2N, okay, NH and CH3. Now again, so this is what? This is a primary, sorry, this is a secondary, right? So this is a secondary. So two groups are attached, right? So this is a secondary amine is obtained. Now further, what you are going to do, again you are going to treat with excess of uh, alkyl halide. Okay, next is excess of alkyl halide. So this will be replaced. So it will be CH3, CH2N, CH3 and CH3. So how many alkyl groups are there? Just see. So one, two, and three. So this is a tertiary. Okay, tertiary. Now further, again, if you treat it with excess of alkyl halide. Okay, what you obtained is quaternary ammonium salt, that is CH3, CH2, N, CH3, CH3, CH3. So it forms a quaternary ammonium salt. So this is the alkylation wherein we are doing that all the that is all the three types of, if you treat it with less amount of methyl alkyl halide, then only primary is okay obtained. If the alkyl halide is more, okay, then secondary. If it is in excess, then tertiary and quaternary is obtained. Okay, based upon the amount of alkyl halide, all type of amines are obtained here. Next is aromatic amine alkylation. Next is what? Aromatic amine alkylation. So aniline, if you treat it with methyl bromide, okay, you can treat with alkyl halide, like the alkyl halide taken is methyl halide, methyl bromide, okay. It so here also the same, one of the hydrogen atom is replaced by your CH3 group, okay. It forms a secondary uh, amine. Then again, if you treat it with excess of alkyl halide, then it forms a tertiary. Again, excess will give you a quaternary ammonium. So also you are forming what? Aromatic amine. Okay, we are doing alkylation of aromatic amine. Next is acylation. Okay, acylation. So amines, as they are basic in nature, they react with acid to form salt. Okay, so whenever the amines they are basic in nature, so when they react with acid, they form salt. So aliphatic and aromatic primary and secondary amines, they react with acid chlorides, anhydrides, and esters by nucleophilic substitution reaction. So they undergo nucleophilic substitution reaction, and this is called as alkylation. So you can see your aniline, when you treat it with the acid, okay, it gives you a aniline chloride. So it forms a salt. Okay. So it undergoes a acylation reaction. Okay. So the next is carbalamine reaction or isocyanate test. Okay. So the difference you need to know is cyanide, okay, or they are called as nitriles. So here they involve N bond. Okay, your CN, so that is C triple bond N, is called as a cyanide or nitrides. Now, what is this isocyanides? Isocyanide is NC bond. Okay, the connecting atom is nitrogen, so it is NC bond. Here it will be carbon will be attached. Okay, here it is nitrogen. So aliphatic and aromatic amines. So if you take aliphatic or aromatic primary amines, okay, again primary amines is a condition on heating with chloroform and ethanoic potassium hydroxide, it forms isocyanide, isocyanides, or they are called as carbalamines. Okay, and these are foul smelling substances, that is they are very bad smelling substances. Okay, so here the connecting agent is nitrogen, so NC bond is called as the isocyanide bond, so we obtain carbalamine. So secondary and tertiary amines, they do not undergo this type of reactions, so they do not undergo this type of reaction. Only primary will form the carbalamine test. Okay, this reaction is known as the carbalamine test or isocyanate test, and is always used for primary test. Okay, it is used for the primary test. Okay, for testing the primary amines. Fine. So we'll see one example based on the carbalamine. So if I take a primary amine, that is methanamine, again methyl, if I take methylamine, if you treat it with chloroform CHCl3 plus ethanoic acid, and if you heat it, Okay, you heat it. What you obtained is CH3 NC plus 3 KCl plus 3 water. Okay, what you obtained is what? Isocyanide. You obtain isocyanide group. Okay, then next is if I take a aromatic group. Okay, aromatic amine plus CHCl3 plus 3 KOH. If you heat it, you obtain what? NC. Okay, NC like this, plus the byproducts. Okay, plus the byproducts, that is 3 KCl plus 3 water. Okay, so this name is phenyl isocyanide. The name is phenyl isocyanide. Okay, and this is methyl isocyanide. What is it? Methyl isocyanide. I hope this is clear. Okay, so one more very important reaction. So here only remember that only primary amines will undergo carbalamine test. Okay, and this is one of the important tests for considering to check whether the amine is primary, secondary, or tertiary. So because secondary and tertiary amines they do not react. So if it gives a positive test, that means it is a primary amines. Okay, I hope this is clear. So the remaining part based on amines, so we'll discuss in the next class. So in today's class, we have discussed about what are amines. We have studied about what is the classification of amines. We have studied about the structure of amines. We have studied about the physical properties and some of the important reactions. Okay, in the next class we'll be discussing about the remaining parts. Thank you. Have a nice day.